Okay, welcome back. It's time for the second of our 4 talks this year's Creativity Society. I want to thank the board of the Creativity Society, Myron Jackson, Corey McCall, Pete Gunner. They're the ones who appropriate the funds, which will help with y'all's expenses. I'll write you a check tomorrow. And I also want to recognize the fellows of the Institute who are here. There are several online. Anthony Neal and Charlie Herman I know are there, but I'm not sure who else. Do I have other fellows online? Well, you don't have the list of fellows memorized, do you? But Katrina is a fellow, and Gary is a fellow. And if you want to know what a fellow of the Institute, what that means, it means you're going to have to do some work, or you already did some. And Bob is going to be invited to be a fellow as soon as he's finished leading this reading group. He doesn't know it yet, but essentially, as Katrina can tell you, this is your initiation by fire. You have to lead a reading group, and then after a few years, you have to do it again, right? So Anthony has led a reading group, I know, and so anyway, every semester the AIPCT chooses a work or two to work our way through. Obviously, during COVID, we did it entirely online, but we're back to meeting in person, which I like better.
Yes.
But in any case, so thanks to the fellows and thanks to the Creativity Foundation for supporting the ongoing work of the AIPCT. All right, with that said, it is time for the second paper, and Gregory Caramenico, the co-author of our book, is a lawyer in New York City, but does not let that get in the way of his serious pursuits, which are raising his son and working in the intellectual domain. I'm sure lawyering pays better than professoring, but yeah, so anyway, Greg is the co-author of this book, and in particular said that the exciting advances in neuroscience, neurophilosophy in the last 10 years give him occasion to update what he had to say in this book about consciousness and the hard problem, and in particular he has discovered some of my friends, the enactivists. 2 of my favorite enactivists, Sean Gallagher and Ralph Ellis, are also committed personalists. Enactivism is very, very sympathetic to personalism, and so not all of the enactivists are aware of this, but he'll tell you who the enactivists are.
Although you will unfortunately see that some of the enactivists that I cite are less on the spectrum toward personalism.
Yeah, they're all out there, and really the sort of reigning father of this viewpoint is Jaak Panksepp, who died a few years ago, and is really quite neutral on the question of person. He's so physiologically and anthropologically oriented that it just doesn't occur to him to confront that particular problem. But anyway, so with that said, make Gregory feel welcome.
Hello. I apologize. I'm regaining my voice after 2 weeks ago I was sick. I lost it sort of back, but I will speak up to the extent that I can. So 2 disclaimers. I am really a historian, not a philosopher. So sort of the way I approach both the problems in reductionism and the problems of contemporary neuroscience have a lot to do with the evolution of those fields and with the way that various metaphors, many of which I think are either incorrect or excessively reductionist, came to characterize neuroscience and came to characterize research. And then also the other disclaimer is that I haven't really kept up with work on emergence, and I've read and heard snippets of some great things about emergent systems theory that I think support the line of reasoning that Lynn and I took in our work, but I'm not going to discuss those. So when we came to this topic, there was a lot of what I would call really great, maybe hubristic enthusiasm about where neuroscience would be and where it would go. So there was a project called the Human Brain Project that was supposed to have completely mapped all of the neuronal connections of the brain in a decade, which fell apart 5 years in when most of the scientists quit and only the computer scientists were left. And so they decided just basically, there was this one founder who was very enthusiastic and continued. So I'm being overly simplistic here, but the project failed because they took on an immensely complicated area thinking they could model the Human Genome Project, and they failed. So there was a lot of this kind of thinking going around that said that either a mapping approach to the brain, whether by mapping neuronal connections or trying to map like larger networks within different regions of the brain, or trying to create a different type of map, a physical structural map of the locations of the brain using functional brain imaging, like functional MRI. The idea is that one or more of these approaches would then help to show how mind emerges from brain and how what we would think of as higher functions, or at least functions that we associate with humans and to some extent with vertebrate animals that have more complex brains, how those things came to be. And so one of the things I had wanted to do was to sort of deconstruct these and to look at ways that these might actually be counterproductive to more practical problems, both on the clinical side of neuroscience and also on the sort of evolutionary behavioral biology side. What kind of problems could be solved? And how do you approach better problems, and how do you create better experiments? And when Len and I started talking about the book, one of the things that at the time I thought was pretty useful was combining that sort of critique with a strong positive argument that the human self exists, that a core self exists, that a person exists, and that the self and the person, although are not identical, that they are very much related. And so one of the things that I think was helpful with this also was Len convincing me that we should very much take on the idea of soul and use the word in English, which I was a little bit reluctant to do at the time. Subsequently, I think I've drifted a little more towards rationalism, and I'm much stronger in my belief that humans have a core permanent self, and that the social self may change, the performative self may change, but that selves are real, but that also that at a certain point you can sort of look at the self from so many different philosophical or psychological perspectives that you can convince yourself it doesn't exist. So those are a couple of the big picture ideas that I was thinking of at the time. And then one of the things I think that kept striking me is the claims that people were making about what neuroscience was going to do. There was this idea that it was going to transform criminal law. There was this idea that it was going to transform studies of decision making in business and economics. And all of these ideas were taking for granted that what was being measured and studied in many laboratory settings was in fact a correct approximation of both how the brain works, but then also an approximation that we could use to make predictions about how individual people might behave or respond. So those sorts of ideas were obviously and are problematic, but I think there's been a lot of failures in neuroscience. Some of them philosophically instructive and interesting. Some of them actually sort of disheartening and depressing. The failure of pretty much every model that we have for anti-dementia drugs, every Parkinson's and Alzheimer's program with one or two exceptions has failed. And on the theoretical side, a lot of ideas people had about how quickly they would be able to create useful neuronal maps to look at assemblies of cells and firing patterns. They just finished the fruit fly connectome last week, or 2 weeks ago. It was a piece in Science. We were supposed to have hit the human one by now. So anyway, so that's just by means of background, because I think one of the things that's changed over the past decade is I've become much more interested in work that has bolstered the positive arguments that Len and I have made, as opposed to focusing on the critiques we make of both philosophy and of experimental neuroscience. So see, I've become a little less cynical in the last decade. Just a little.
We also have to mention that Greg has married and fathered a child in that decade, so obviously no causal connection, but...
Yeah, but I also went to law school, so you have to make the... one might have expected those two to have sort of neutralized each other, but... I generally don't get too involved in jurisprudence, though, which I think is what really drags you down if you start thinking that deep in legal thought. So the first thing I wanted to do is to talk about two areas where what I think of as our sort of negative predictions were unfortunately correct, and what they narrowed down and what they rule out in the philosophy of mind. And then to talk about two complementary approaches to our work that existed 10 years ago, existed 15 years ago, but have much better books have come out. And then lastly, just to touch on recent neurotechnology that I think is very exciting because of what it shows us about the relationship of the brain to the outside world. So, the negatives. The failure of computational metaphors and cognitive science as models of the brain. There were people writing little bits on it. Kurt Danziger, the Canadian psychologist, had written a critique of the study of memory, talking about the failure of computational metaphors. There were some very good articles. Ulrich Neisser had written pieces on it. But since we wrote the book, there have been much better works. Matthew Cobb wrote an excellent history of contemporary neuroscience called The Idea of the Brain. And the sort of pathway that Cobb traces is the way that metaphors, all of these, everything from brain is a computer to the brain is a sensory processor to the brain is designed to control the motor functions of an organism, all of these sort of single model function roles, analogies, whatever you want to call them, for the brain, and then the specific verbal metaphors that are used to support them. He sort of does a thematic approach. He goes through each of them and shows you where they succeeded and where they failed. And one of the things that I thought was most interesting to our point is that you can take a good model, you can build great model systems from it, but you won't necessarily have created anything that functions the way that the similar systems in nature do. So he writes, for example, about the evolution of neural nets and of the rise of cybernetics. And unlike other histories of cybernetics, such as I think it's Kidd or Reed's recent one, this isn't a celebration, this isn't a critique, this isn't talking about what it does in society, it's just saying people created this whole field with an idea that they were modeling what brains do. It turned out they weren't, in fact, modeling what brains do, but they came up with a lot of interesting stuff along the way. And this got me thinking somewhat about, it's sort of an inadvertent example of what one of our arguments about human personhood, which is that human beings tend to remake the world the way that they think it should be if they made it. Everything becomes an artifice. And this is, I think, one of my big problems with the history of technology outside of the positivism, and also the grim positivism, because the way I look at it is you have the old sort of Whiggish positivism about technology, that it's always getting better and it's always improving things. But then you have this overwhelming pessimism that seems to think that technology is going to do everything that people claim it's going to do, that it's going to succeed. And in neuroscience, there's been a lot of this, and I've really appreciated the criticism of computational brain models that's come from neuroethicists and from people who are very concerned about the implications of neurotechnology. But so much of it's failed in the last decade that I actually am more concerned about people thinking it works and applying it in law and business and society when in fact it doesn't. And I think we did a really good job of approaching this idea, both in the negative of criticizing why it doesn't work and also in the positive of saying, but this is an interesting example of human creativity that we conflate the most complicated thing to have evolved in nature with complicated things that we can make or we can build. And so there's been some other pretty good work on it. In addition to Cobb's work, there was a really well put together critique of neuroscience mechanical biological dualism that I saw recently, which I thought was funny, about people trying to rework their brain models to account for things that they were seeing in artificial intelligence systems. Which I guess if you're really committed to the model, then you would want to do that. One thing that I thought was really great is there is a relatively new view of the brain as a system for taking action. And the interface of the brain as a system for taking action with the engagement of the brain with the body, and particularly in proprioception, and then the extension of that into the social world. And what I've appreciated about this idea is that you have the brain working as an internal system. All the stuff the reductionists like to talk about, monitoring physiological processes, being aware of where we are in the world, our proprioception, our positional awareness. But then this model says, but then there's a reflexive self-awareness that we build in. And then there is the very culturally specific awareness of the artifacts we use. And all of these things reshape connections in the brain, but they also reshape, well, I shouldn't say they do, we actively reshape ourselves as we sense and as we perceive. Other animals do this too. But recent evidence is actually showing that things and events in the world can acquire meaning, and very different meanings, through brain-mediated action. And I know that sounds like common sense, but there are many people in neuroscience who may have disagreed with that in the past. There's also a really interesting idea that the brains examine the relationship between changes in sensory input and changes due to self-initiated output. And we now know that this is often conscious and this is often reflexive, which is something that computer systems, artificial systems simply don't do. So those are some things that I think have been helpful from the more, I don't want to say hard science end because it's all biology, but the hard science end of neuroscience, the computational end. I also think that we've really learned that large-scale dynamic properties of the brain, things like synchronization and neural fields, are very interesting, but they don't really explain much about the way that self-awareness or self-consciousness is constructed. Which brings me to the second negative point that we made that I think really has bolstered our claim that humans are a socially, physically, and psychologically distributed system, which is localization has failed terribly. fMRI localization. It's great in one specific clinical sense of understanding what specific regions of the brain, and by extension the peripheral nervous system, are necessary, and kind of what abilities we lose when those are damaged. But it is really bad for building a sort of bottom-up model of modularity. So for instance, there's this quote that I wish we had put in the book that I had not heard until recently, which is that Richard Gregory said, "The argument from lesions," which is the classical 19th century argument that if you destroy or damage part of the brain in a laboratory animal, or if you observe patients with strokes or traumatic brain injury, you can deduce from the location of the injury and from their specific loss of function where that function originates in the brain. Crude idea, old, there are much more nuanced versions of it now, but the Richard Gregory quote went, "The argument from lesions, unless we're careful, always leads us to utter rubbish," which I still pretty much agree with.
We said that they show necessary but not sufficient conditions.
Yes.
We put it in logical terms.
Yes, which I think is very helpful. And it's been interesting watching where that's taken us, right? So, cells are electronic components, and as one recent author that I thought wrote very nicely, a wiring diagram will not show you how cells function in a network, and that's before you get into the feedback from behavior and from these various other components. For instance, there's also this really interesting book by Vidal and Ortega called Being Brains, where they look, the authors look at localization claims, which are staggeringly important in neuroscience, and they point out that the best of them never quite add up to the function that's being attributed to them. You can't talk about agency or decision making in terms of what happens when there's frontal lobe damage and someone's ability to make decisions is impaired. We now know that despite one of the best researched areas of the temporal lobe is the hippocampus and the hippocampo-amygdala complex, it doesn't really tell us about how memory is extended and how memory is used. It has been somewhat helpful in understanding the neuropathology of memory, but even that, unfortunately, we are nowhere near close to being able to solve. And so what I think we did that is helpful is not to sort of stop there the way that some more cynical writers did and come to a kind of pessimism about understanding the brain, but saying that we need to be realistic about what we're trying to understand, and we need to be honest about, are we trying to solve for a clinical problem? Are we trying to understand how a biological system came to support the people that we are? And if so, how would you look at that with science, and what tools would you have? And there have been a few approaches that I thought were useful, but the two best were both books that I disagreed with. One I really disagreed with, and I thought it was still a brilliant take on the long and deep history of life, even though I don't share the author's conclusions. So has anyone read Godfrey Smith's book, Metazoa or Other Minds? All right, cool. So then I actually can just very, very brief synopsis and then talk about what evidence is marshaled. So his argument is that since nervous systems have been shaped by the evolution of agency in animals over deep time and over evolutionary history, and that you can't ignore agency as a behavior, and that we have focused too much and too exclusively on sentience to the exclusion of focusing on agency, which I thought was a really interesting point. And the insight there is that some of what Lynn and I described as properties of the human person and the mind, might best be described as existing on a continuum across various animal genera and species. And by looking at this continuum, you can sort of see where certain behaviors become not just more complex, but more goal-driven and more agency-oriented. And you can look at other places where animals and various very, very different types of animals develop self-awareness and sentience, more or less. Now, I take some issue with some of the species claims and some of the claims he makes about specific cases. But I think this idea of sentience and agency as separate strands that sort of coalesce in what we're looking at in humans, but don't always coalesce in other highly adapted, advanced is such a loaded word, neurologically and phenomenally complex animals, we'll say. How we can see those things emerging across a continuum. And the reason why I think this is so interesting is that I think that our use of the idea of soul as opposed to self is in part an argument that what we're calling the soul is a bit bigger than just the psychological self and the inner self, and it involves the outside world, and it involves a certain measure of, I guess you would say, I said, originally I wrote this and I said engagement with world and use of the objects in the world as extensions of the mind, but I think it's more than that. But I think it's also the creativity to know how to remake the world in our image. And one of the things that I like, I'm very interested in this idea of artifice and remaking the world and conceptualizing the world as part of this broader definition of the person and the soul that we use. And one of the things I thought was really interesting about looking at this continuum of what he calls other minds is that it's really helpful in saying, that is more a good point about human rareness or uniqueness, rather than self-awareness, which we see many levels of self-awareness across nature. That's also something I've become more convinced of in evidence since I wrote with Len, is the complexity of certain animal minds. I think we've reached a point in evidence where we may not understand their phenomenal experience, but we can make certain objective statements about the very different types of intelligence and of self-awareness that exist in nature. Which weirdly hasn't, I think, I was thinking it might have actually hurt our argument, but it didn't. I think it bolstered it in ways I hadn't thought. The other part of this that I thought was great is there's a model where you have the evolution of sensory and evaluative aspects of perception. And those really vary based across an animal's needs. So there's an argument that you have these invertebrates with amazing sensory abilities, but incredibly limited awareness of, say, losing limbs, experiencing pain and things, and an ability to function, reproduce, keep going in spite of those things. And then you have the other range of it in sort of many mammals and some non-mammals where every experience is tied to emotion. And there's kind of a backdrop of emotional life and emotional development. So one sort of demarcation that I think you can make, and I like using the idea of soul, is to say that what we're talking about as the soul is a composite of how all of those evolutionary factors play out in human beings, rather than personhood, which I'm very interested in some of the recent work on personhood and agency and personhood and enactionism, but it's not necessarily the same thing, and I think that the boundaries there are a little clearer to me. I mean, they're never going to be clear, but they're a little clearer than they were a decade ago. So that's the one component of this. Now we come to some of the enactivism. Although it may not be the enactivism you're hoping for, there will be some enactivism. So I sort of walked backwards into enactivism from being interested in what I thought was a very complete, but one of Andy Clark's better ideas, which was extended cognition, and wishing that he had kept working more on extended cognition before going into the other brain models that he subsequently worked on. And I started reading enactivism in the context of extended cognition, which is basically this idea that our awareness of the world involves a whole lot of objects. It involves our use of tools. It involves our use of other people. It involves our observations of things. We rely on all sorts of external devices to think, and to some extent we always have. That's sort of a human trait. And what I really appreciated about enactivism was just taking this a step further and making cognition something that involves action. Sort of getting us away from the never-ending emphasis on interiority and on just too many arguments about what minimal consciousness you need, what minimal awareness, what minimal personhood you need, and arguing for a kind of maximalist idea of personhood. But the approach that actually appealed to me the most is not purely enactionist. It's somewhat idiosyncratic. It was what Evan Thompson came up with in the 2015 book, Waking, Dreaming, and Being, which also argues on a continuity that you can't escape both action and process if you're talking about what people are and what people do. And what Thompson calls the brain a self-specifying system. And a system that specifies itself by action, by being a self-perpetuating whole in relation to the environment. And he sort of centers this around this idea of I-making, that you create at the biological level, the social level, at the psychological level. You create these systems that specify who you are, but other people help define those things. And the physical processes of your brain aren't projecting these things. You are these processes, and you are also the social processes, and you are also the psychological processes. Now, some of this I would not have necessarily phrased, I don't think that we are our processes, but I do think that this gets us out of a lot of emergentism, some of the emergentism I've seen in recent years, which is a little too much like, we wake up one day, you're building up a process, and suddenly you have humanity and you have the human mind. And I think that both the evolutionary approach that Smith takes, which is a little more out there, and then the approach that Thompson takes with looking at brain states, body processes, and social processes as sort of building up as different levels of making the self. I like that more than emergentism, and I think in some ways, or at least the kind of really strong emergentism that I certainly was seeing a lot of when we were writing this book. I think there's something to be said for looking at a continuum of processes where we are defining ourselves physiologically, we're defining ourselves socially, we're defining ourselves psychologically. But Thompson goes a step further and suggests that when we look at internal body states and brain processes that register them, there's a self-specifying link, and that this link contributes to a sense of self as a feeling of one's body that is doing the thinking and acting, and also a feeling of oneself as the thinker and the actor. So I thought that was an interesting approach that complements some of what we were trying to say, particularly in our critique of agency research, because so much of agency research was looking at, is the brain making your decision first? Are you aware of your decisions? Do you know when your decisions are being made? Is there a difference between conscious decision making and sort of habit and predilection? And I don't think those were very robust studies, and I think a lot of those have suffered in the replication crisis that swept through a lot of psychology. But I think looking at the processes, this idea of self-making or I-making is just much more productive. And then the other thing that I thought was really useful was the way that Thompson describes this self-specifying system in both biological and psychological terms. In the biological sense is maintaining the body's sense of integrity and self in relation to the outside world, the environment, in homeostasis and things like that. And then looking at the way that we do this socially, and the way that we do this in reinforcing our waking lives with other people, and in reinforcing this in our dreaming lives with ourselves. That said, I do think that I take a much stronger view on the continuity of the self than many of these writers do. Recently I read a book called Inwardness, which does this, it's like a little tiny book that goes through all the different theories of what the self is and then criticizes what they are. And in reading it, I kept thinking, Len and I look at all of these and we construct that you put them all together and that's who we are. And I think that similarly, when you look at this idea of the different processes that lead to the creation of the self, sure, I'm very excited to see that there is a neuroscience of complexity and that it's being taken seriously, but I also think that we're at a point where we can be a little more confident about it, even if we know that it's a really daunting task to say someone's going to model the creation of the self from the brain. We at least have an idea from biological models about how that would happen. And we also know that we don't need to take a reductionist approach and try to work backward and say, okay, here's where our sense of identity comes from. Here is where our sense of continuity with the past comes from. You know, these things exist in a continuum across species, and these things exist at different levels in human beings, depending on whether they're sleeping or waking, or whether they have what their state of mental capacity is. I forget what we had an expression for that, but I couldn't find it when I was reviewing the book.
One expression that comes to mind is one that comes from James, where he talks about we have ownership of our own dreams. I don't think that's quite what you're looking for.
Yeah, but it was related to the ownership question.
If you have a dream, it's your dream. It's not somebody else's dream.
But exactly, and that your own dreams are going to shift greatly. I think the neuroscience of dreaming is very interesting. It is a new field. There is a pretty good book by Jennifer Wint on creating an experimental process for studying dreams and what we can learn in neurophenomenology and similar things about it. Unfortunately, my research was in functional brain imaging and memory systems, so I know nothing about dreams. But if anyone feels inspired to work or read on it, I think that would be great. And then one thing I wanted to touch on that I think has gotten really a lot of press from a reductionist perspective that I think has really come to the opposite is the emerging field of brain-computer interfaces. So brain-computer interfaces are machines that translate neuronal signaling into physical action. Usually physical action by a prosthetic limb. It can also be machines that translate brain signals that would go to the vocal cords into voice. The major applications are medical and therapeutic, and those applications are very invasive. They require cortical electrode interfaces, and there's a lot of technological issues. There's issues with preventing infection. There's issues with maintaining the technology. And there's a milder version of this technology that is getting weak signaling from outside of the skull and being used to control video games, remote control toys, and things like that. What's really interesting about BCIs is that people were saying, "Oh, this is like these machines are reading your mind, and they're showing how seamlessly the computer of the brain engages with these computers that are artifice." And I've done some deep dives in brain-computer interfaces, partly because I had written an article on the legal implications of them. At the time, from a patent law perspective, and just from what happens when the technology goes out of fashion, and what do you do? And I found out what happens when technology for a lot of this stuff goes out of fashion is they have to take the devices out of the people. So there are some continuity issues there, but there's a lot of advances, and there's a new book coming out which I haven't had time to read. It's just coming out on sort of more deeply the privacy issues and the ethical issues of not just brain-computer interfaces, but brain monitoring and brain state imaging and those things. But when I was writing about it, I was more interested about, at first, kind of what are they claiming and what can happen. And then subsequently, I started reading through the literature, and you realize what people are calling mind reading is actually a really creative and engaging use of tools that shows both the very much really extended cognition. Like, you can't really extend cognition more than this. And also it shows a lot more agency on the part of what the recipient of the device is doing than it shows the supposed seamlessness of the interaction between the brain and the machine. So for instance, people are learning how to use the machines. They have to learn how to control the devices. It's often very imprecise at first. It takes a lot of tweaking. The computer is associating neuronal activity with patterns linked to muscular control, muscle contraction, muscular control of voice, things like that. And it's very exciting from a therapeutic and medical perspective, but it's I think, bolstering our claim that much of what people see as models of the brain or as competitive system, artificial minds, are really extended tools. That's not to say that they can't have all sorts of negative consequences or whatever, that's a separate argument, but I think that there's a really exciting and interesting aspect to this field, which is it shows just how finely tuned we are, so to speak, to be able to control these things and to be able to engage with them, when often the technology on the other end is very crude. And so it's the brain adapting to communicate with the device more than the device to communicate with the brain. There was a really interesting quote. There's two. One was from some of the scientists that were working on these recently with monkey models, where it was talking how much longer some of the rhesus, the monkeys that they were doing these studies, took to learn how to control the prosthetic devices. There's also an interesting quote in Matthew Cobb's book where he notes that these developments really highlight the plasticity of our brains, because no one cracked the neural code for volition and planning. They learned how to translate patterns of firing in the brain that we don't really understand or have any idea how to replicate into the movement of a robotic arm, and then the patients then learn how to keep using them. So I think this is a very fruitful area for a lot of research. The area that I think it would be most interesting in is looking at it from the perspective of enactivism, and what does it mean to be engaging in the world this way when it's mediated through a machine in a much more direct mediation than the rest of our engagement with machines and technology. And I also just think it's been really interesting hearing this as an example of reductionism, because I think it argues for the opposite. Lastly, I wanted to just touch on two things that I would change if I were writing a book now. One, I think we probably should have done a more thorough job of splitting out different varieties of emergence and explaining what we meant, particularly as I now look at the difference between emergent systems theory, which is something I was very influenced by, and emergent processes and complexity theory, which we don't really touch on but would have been useful, and maybe a little less on emergence in a kind of strong emergence argument as it came out of the analytic philosophy of mind. That would be my one critique. The other critique is I wish I had been more aware of the philosopher Guarneri's work on Nyaya and on classical Indian philosophies of logic and the logic of thought. Unfortunately, I don't know Sanskrit. I'd love to learn it, but didn't have time. And when we were writing this, I had only read some cursory surveys, but I think it would have provided a nice counterpoint to some of the arguments we were making about what is a composite human being and how much of a role does rationality play or not play in that. But I think that is interesting, but I think that's much less of a quibble than the emergentism. So, sorry, that's a lot of cognitive neuroscience. Any questions, comments, things that you think I misquoted a philosopher on? All right.
I have one. Are you being critical of the idea that the brain is really use-oriented? Because one of the reasons that I bring that up is because, just a simple example, you wake up one morning and you have floaters.
Yeah.
Those are folds in the back of your retina, and your brain has not yet figured out that they're of no use. Give it a couple of days, the brain will eliminate that. You won't see them anymore. And so it's a circular argument, but I built in the reason that the brain knows to eliminate those things is because they're of no use. And so what I want, it might just be a way of talking about it to say it that way, but it does seem like magic that the floaters disappear, not because the folds in the retina are gone, but rather because the brain's ignoring them.
Yeah, I I would say that my criticism is more that the idea of the brain as the sort of the mind as being utility oriented. I think you have a lot of utility oriented brain processes and functions that have all been selected for separately over evolutionary time. But I think that there is, and this is where I embarrassingly mispronounce his name, but Basaki, the Hungarian neurophysiologist at NYU, wrote a great book on the idea that it's about what the brain is doing outside to the world.
You mean Chicks in the High?
No,
Not the flow
not the
guy?
flow guy, not the
Okay.
flow guy. Yeah, not the flow guy. No. Georgi Basaki wrote this Patterns in the Brain, really good book. The idea that the brain is more about exploration, and particularly when we get into the emergent properties in the mind, it's more about doing things to the world than just accomplishing goals in the world. And that it's also much more about projecting the inward world out than looking at the outward world and figuring out what to do with
But
it.
but you want to reject the interpretation of that in just utility terms.
Yes.
That happens, but
I have an incredible dislike of any utility arguments, whether they are political, social, moral. Yeah.
okay. I just wanted to get
Yes.
clear on that.
Yeah, I'm back to the statement you made. Evolution is shaped by agency. That seems counterintuitive with regard to natural selection. That somehow there is some other factor shaping.
It is. I mean, I would say there are versions of natural selection that it is incompatible with. But I don't think it's any more incompatible than looking at something like sexual selection or any of these other kind of processes that are ultimately subject to natural selection, in that if they reduce fitness, they disappear. But they're not
If they
necessarily...
reduce fitness beyond a certain point.
Yeah,
Sexual
exactly.
selection does reduce fitness, but
Not
excessively.
Not excessively. And I think that you have an analogous situation with agency and probably with the evolution of cultural behaviors. I don't think many of them have the utility, especially the ones in certain animal species. I don't think they have the utility that the behavioral biologists attribute to them necessarily. I think that they have managed to become at least enabled by heredity, but maybe enabled by heredity, maybe not, but they're not... I don't think that we can see them as, or that the explanations that try to see them as enhancing reproductive fitness work. And I think agency-based stuff, particularly interactionist approaches to behavior, including in invertebrates, don't really, the models, the fitness models that I've seen don't really work as well as some of the proponents think they do.
Well, where would survival fit here then? Because it sounds like that this would be shaped by some kind of need for survival, some urge for survival. If there's evolution shaped by agency, what shapes agency? Is it a need to survive?
Yeah, I mean, you could certainly say the negative argument shapes it, which is that without a need to survive, or with behaviors that contradict it beyond a certain point, that gets out of the gene pool pretty fast, the animals without that need to survive. But I think agency evolves from many things, not just a sort of survival urge.
But it's.
let me complement that by saying that there are things that evolve that might originate in enhancement of the likelihood of certain genes being preserved, but there's also a kind of functional autonomy of ideas that we have to pay attention to. Flowers may bloom in order to attract insects that will pollinate them, but that, as Darwin pointed out, that doesn't quite explain why they're beautiful. And when you get into an example like sexual selection, which is a related point, all kinds of features emerge which in Gould's language are, what do you call them? The architectural term.
Spandrels.
Spandrels. That is, That is, they may have a base in evolutionary survival, but they take on a functional life of their own, and there are there's certainly characteristics of human thinking of which that is true. Curiosity is a good example. Aesthetic interests are another example. Aesthetic interests may have an evolutionary base, but they have expanded far beyond that. There's a wonderful example, you may remember who gave it, that we enjoy. I don't enjoy Wagner, but one goes to see Götterdämmerung because one wants to understand what happens if you are given a piece of gold, etc., etc. Right? That's not why people go to see Wagner.
You got to see the bizarre stagings and what various directors are going to do with them.
Right.
But it says there's two different motivations, two different development themes, I think. What I'm hearing in natural selection is it's the origin continues to evolve. In other words, it's coming from what was into what is. Natural selection. There's no purpose. It's blind. What I'm hearing is some kind of goal orientation.
Well, I think that it's more about creatures directing their own evolution inadvertently.
We make that point in the book.
Changing its course, stalling extinction, creating new niches in the world through agency, and doing it in such a powerful way that it has a kind of reverse feedback on selection pressure itself, for themselves and for many other species. And I'm not just thinking of humans here. If anything, I think that that's the one aspect where how much we differ, but we may differ, Glenn and I may differ a bit.
I think we differ that much.
Okay, like in terms of what I see in terms of animal agency and sort of, and I also think that some of the more really disturbing aspects of humanity center on our agency to remake the world.
Sure. But purposiveness itself is an evolutionary vector.
Yeah.
It may be a spandrel to start with, but purposiveness, purpose has evolved because of natural selection, but purposiveness is quite another thing. And there's a certain, and I do believe it's in other species as well, that there's much more autonomy in the more complex species than there is in the simpler ones.
Yeah, and what's interesting is that you even have species that are really complex in a sensory way, but don't have the autonomy and the purposiveness, which is sort of...
That brings me to my question. I'm glad you said that.
Also,
did you have somebody over here?
You've been raising your hand a lot, so why don't we...
Oh, that's okay.
You want
Anthony online.
Okay, let's
go.
Okay, a good paper. Just as a point of information, I've had a chance to be around John Bickle, who does neurophilosophy, and he's one of those ruthless reductionist guys.
Oh, yeah.
And then when I was at CAU, Ralph Ellis was a professor, or still is a professor as far as I know, at CAU.
He's still there.
Okay, yeah, I got a chance to talk to him a lot, sat in his office, and great musician, by the way. But anyway, my question has to do, certainly in the short run, when we talk about agency, usually I don't see a lot of work on how things like, particularly as it pertains to the human brain, things like frameworks or what Heidegger might say, something like thrownness, or even what Bergson would say, something like duration. The moment, your experiential moment that you're in, how that affects and changes what we might even consider to be our notions of agency, and creates certain types of perceptual framework which might readjust the brain, and also things like class. All those kinds of things, when we say certain things like natural selection, but in human environments, right, we have things like war and all of these kinds of things that we tend to think that, we end up in a certain place because of just kind of, this is where I was supposed to be, but there are all these other things that happen to create a sort of framework for that person to brain to kind of develop in a certain way. And what I mean by that is, so we know if you don't learn certain things by a certain age, it becomes more difficult to pick up those skills, right? But because of class and all those kinds of things, certain things cannot happen or may not happen to certain segments of society by a certain age. It doesn't mean that the brain was limited in a certain way. It just means that, their experiential moment. So how do you weigh those against each other?
Well, the deprivation aspect of it, though, ultimately you are saying that the brain isn't receiving the full range of either stimuli, experience, nutrition, whatever that allows sort of flourishing. So I don't see it as being that different from an argument that's looking at the effect of traumatic brain injury or slow disease cognitive deficits in impairing what is the sort of full or normal is a complicated word, but the sort of fully sort of fully realized human mind, right? Like I think they're all gradations of either deprivation or loss.
Interesting.
I would just throw one more thing in there. The issue of the stages of cognitive development that the brain, as it evolves, as it grows, as it matures, there are stages where if that stimulation doesn't occur, the brain myelinates in a way that we don't have the potential that we had initially to learn that particular experience. That way, language would be a perfect example. So if a person is deprived of the stimulation that's necessary in that particular stage, they're never going to get full use of that particular the effects of the brain of that particular stage. Yeah.
And even in normal development, there are critical windows for certain things. And
I would mention the Susan Berry case, though, as a counter.
the what?
The Susan Berry case, fixing my gaze.
I guess I hadn't thought of it that way, but yeah. I mean, I was just thinking of critical windows for language learning, like phonology and sound.
Yeah. Right.
Right. It closes. Now, other forms of learning close much later.
Yeah. Yeah, one of the advantages I have is that I heard phonemes from 2 or 3 different languages as a child, so I'm able to pick up languages much easier than I would have had not.
Although I think it does really depend on the languages, because I grew up with 2 Romance languages in English, and so it helps a lot, but it doesn't really help with Arabic.
Well, it doesn't make it simple.
Yeah, but I have friends who grew up with like really sort of phoneme-rich bilingual homes with like Arabic and English or Turkish. Totally
different phonemes.
And they, as adults, like I watch them in classes, and I might even pick up the grammar much more quickly and the Latin syntax, but like they can do the sound, and I'm like, wow, this is
The last thing I want to say is that what we were talking about. Agency, evolution agency. Stuart, I think what you said is encapsulated in what Stuart Kaufman calls life bubbling forth. Life bubbles forth.
I like that, yeah. You had a question as well?
Yeah, this kind of is going to go back. And you had just, before 2 questions back, you had kind of, during your talk, when you started talking about the invertebrates, and that I guess the example you were given, or your point was, they don't have emotions underlying. They lose a limb, and they don't have emotions associated with that. So, if you, maybe you could extend that a little bit. Were you getting at, this idea, like for example, E.O. Wilson's work, where he looks at ants, as an invertebrate, they have an exoskeleton, they have an exobrain, if you will. In other words, like the ant community is a brain in and of itself.
I'm working backwards from that, because that was my starting point of thinking about these things.
Okay.
And then I started, especially the Wilson thing and the idea that the one way of looking at invertebrates is you can see the social insects like ants as having the same relationship to mind that multicellular organisms that aren't really multicellular but are composed of many unicellular organisms but function as a unit have to body. This idea that they're an aggregate sort of brain, even though they're not that complex. I thought that I still think that's very interesting. I've gotten more interested in the idea that I've read two philosophers on recently whose names I should have written down and have forgotten, but I have them in my notes. And also in Godfrey Smith's work, where he takes it a step further and talks about maybe it makes sense for these animals to have a more reduced phenomenal world because their goals are either functioning socially like ants, that sort of thing, or because it doesn't really benefit them to experience sorrow and pain in their short lives. He compares, I think, a limb being damaged on was it shrimp or some microorganism, some small invertebrate organism, to just saying it's sort of like the inconvenience of a flat tire. It's a lot easier to get through life if you're experiencing it that way.
Okay.
Than if you're, and so I don't necessarily buy that whole argument, but it's got me rethinking what I used to think of in terms of Wilson's work and yeah.
And I just wanted to point out, the idea that it's an exobrain, they're all operating as a brain, and that a computer can operate more like the brain of an ant colony than it can as a human. In other words,
that's interesting. Yeah, it's a totally different emergent
the extension
system.
of the social, and they're laying down. For example, each individual is laying down, say, a chemical, a signal to each other, the way that our brain lays down chemical signals to ourselves. So they have an exoskeleton, we have an endoskeleton, and we have an endobrain, they have an ectobrain. But beyond that, they also have this social structure that then we can conceptualize, and now I'm going into Fritjof Capra and the systems view of life, where we can extend what they're doing to our own social world. We can act more like ants in our societies to solve problems. Social problems.
I don't necessarily go down that line of argument, but I see where you're going. I actually read a book that really got me thinking, that I really still stuck with a couple years ago. George Dyson's most recent book, Analogia. Has anyone? It really got me thinking about this way that artifacts created by humans emerge and take on very different roles in society and go very different places than we imagined them. And Dyson uses this fantastic example of the optical signaling that the American military used in the West during the last phase of the wars with Native Americans in the Western United States as an example of the beginnings of the use of both advanced computer technology and advanced communications technologies and how they relate to each other to surveil societies. And then there's this very interesting look at the way that we are part of these really big analog systems, really complex analog systems that use all these digital parts and all these digital devices, but have emerged as something much more complex, and in some ways sort of something that gives rise to a bit of fear if you actually think about it. That is kind of like just a network of small nodes and small components, and we're the ones linking it together.
Yeah. We have an exobrain that's like the ant.
You might also put it that way, but I would say that definitely read Analogia. It also is not coming from cognitive science.
One more. I'm sorry.
I have a question.
Okay.
Yeah, go ahead.
Okay. I'm one who generally thinks that consciousness, through evolution, has enabled emergent properties to become very popular with the use of the brain. In fact, I think that thought and feeling are emergent properties. I think the mechanisms of identification and projection are emergent properties. But most of all, I think the consciousness is itself an emergent property. So when you suggested earlier that you weren't that much of an emergentist, I thought, well, that's kind of interesting given the importance of consciousness to what you would be doing. So I wondered whether you could give an explanation or whether you don't think that what I was talking about are emergent properties.
I do think consciousness is an emergent property. We agree on that point. I'm not sure that I find emergentist explanations to be very satisfactory in explaining two things. One, the continuum that gets us from basic bodily awareness or self to consciousness. To me, a lot of the emergentist work that I've read seems a little too much like one of the worst scientific theories of the 20th century after Lysenko, which is punctuated equilibrium, where, it sounds like, all right, here we are, suddenly consciousness emerges. And I think it's a lot more path and process dependent, and I think even if we can't know the full story, we should definitely try to know as much as we can about how we get there evolutionarily. So that's the one thing. And the other thing is, I agree that these things are emergent properties in the sort of the basic sense that they can't be known, they can't be understood from a bottom-up look at their components. I'm just not really sure that it tells us all that much more. Like, it's a nice, very concise way of explaining why reductionism fails, but I'm not as satisfied with what it offers us in its place.
Let me add to that, and I totally agree with Greg. Emergence is not a mode of explanation.
Thank you.
It's an alternative. It's an alternative to reductionism. And when you're dealing with the rise of elements in the stars, or whether you're dealing with biological evolution, or the rise of the mind, what emergence is telling you, and I'll have more to say about this when it's my turn. Emergence is telling you that you cannot deduce the outcome from the supposed components or ancestors or givens that you allow yourself. I think that's a fact of logic, and I think emergence needs to point that out as a corrective to the reductionism the people who tell you that the body is just 24 hours.
Agree. Emergence is a tool.
It's not a mode of explanation at all. We're gonna need specific explanations for the specific varieties of. The classic example is table salt, right? Table salt does not have the properties of sodium or chlorine. But the explanation of how sodium and chlorine turn into table salt explosively is going to involve valence chemistry and all kinds of. You're going to need to know the chemistry of it, and knowing the chemistry is not going to tell you what the brain is.
Exactly. Understanding emergence to me is more of a logical tool, or at least a shortcut in reasoning that allows us to understand certain things, but I don't think it's an explanation, and I think it's much more useful in deconstruction than it is in sort of construction, so to speak.
Yeah, I was a little perplexed by how you're using the term agency. My understanding of agency, which may be overly idiosyncratic, is a point from Hannah Arendt that action is different from behavior. That action traffics in reason and behavior traffics in causes. And there's Kantian point, the difference between reason and cause.
It goes back to Aristotle too.
So
I'm not quite using it that way.
Right, I'm using it that way. So when I hear you talking about agency of beings who are incapable of reasoning, or who at least can't articulate reasons, I wonder, well, why is he saying that? Is that really agency? Is my use of agency very idiosyncratic? I'd just like to hear more.
So I don't think it's idiosyncratic. I think it's rationalist. Which is not. I think you can have purposive, goal-directed behavior without being able to really reason about that behavior, but to be able to sort of figure out through either trial and error or a mix of instinct and social cues, or instinct and environmental cues, how to achieve your goal. That doesn't really rise to use of reason in the Kantian or post-Kantian sense.
But it would qualify as agency.
Yes.
Rather than behavior.
Yes, that's what I think that agency is as much a continuum as consciousness or a sense of self or any of those other things. I don't think there's a cutoff between. I'm sure if you go low enough in the continuum, there is a cutoff point, but I don't think it exists. That it's a very bright line, and I don't think, especially among higher animals, I think it can be hard to judge. But yeah, I have a fairly expansive view.
Got one more question online I want to catch.
I thought that was a fascinating presentation. I've had some in passing discussions with Randy and others about this, about reductivism in science. A lot of your presentation seemed to be of two things. It said some years ago, neuroscientists and others thought X, Y, and Z, but with further research, we now know P, Q, and R, and then that's used to form some conclusion about how things are and why reductivism does not work. And instead of that, it seems to me the conclusion I would draw would be that the scientific process is ongoing, and maybe reductivism is an open question, because just as what we now know was not known some years ago when you first studied this in your book, some years hence that we now know may be different, and it may be a more reductive approach. It may be less of one. We'll have to see. I would just avoid drawing conclusions, and my own bias on the way to approach these things is Charles Peirce, at least as far as I understand him, and that's that scientists that are very close to these things, the community of scientists, have to look at the evidence and discuss amongst themselves and draw their own conclusions and approach closer to the truth, rather than have philosophers or others legislate to them about what may or may not be the case. I have a friend who is a chemist, a philosopher of chemistry, and we've had similar discussions of reductivism on a different level, which is whether chemical reactions and statements of chemistry reduce in final analysis to questions of physics, which some physicists believe, and others, including my friend, do not, or at least they say the jury is still out. But the point of that is not to say that reductivism is true or false, it's to say that we don't know. And I'm uncomfortable with drawing explanations based on science in some way to reach what are ostensibly non-scientific results. I would rather let the science speak for itself, and whatever humanistic or religious values you think are not encompassed in that, let them be developed on their own without trying to interfere with what scientists may or may not find as far as reductivism goes. Because I don't think people on the outside can legislate to science what they find.
So having done the science at the level of cognitive neuroscience and functional brain imaging and working with some of those areas and the behavioral work, I think if we were just looking at the science, first of all, I don't think you can ever remove scientific findings from both a mathematical and a philosophical reading. The mathematical, because everything's being interpreted statistically, and the philosophical reading, because unless a scientist is really naive about the meaning of the work, there is always a interpretive paradigm, and there is always an epistemic lens, and you're not going to escape those. But putting that aside, looking just at the science, I think if we were looking at where we are experimentally, we are talking about, even with great leaps in understanding, several generations, being several generations behind, having just the raw data and the information we would need to construct a biological model of the human mind. And so even if that turns out to be more reductionist than some of us think it would be, the level of complexity involved is not going to involve the reductionism we have now. It's not going to involve understanding of building up single neuron cell recordings, because the other limit we run up against is the limits of our technology. And the technology in turn its limits are reinforced by a loop about what metaphors and what, not just philosophical metaphors, but what social and psychological metaphors we are projecting into the science, right? Memory science is something where we've taken a lot of metaphors from human experience, labeled reductive elements of those in mice, and tried to come up with models or in implicia or whatever. And we've learned a lot about how the basics of how nervous systems work, but we're not closer to understanding what that means in terms of how the mind works and how the mind emerges biologically. So I think there's very little way you can avoid making philosophical claims any more than there's a way you can avoid making claims about statistics and probability when you interpret research. But that's my bias, and then also having just done a little bit on the, well, more than a little, moderate amount on the experimental side, and worked with people who were doing this sort of full-time brain imaging work. It's just, the more you learn about the systems, the less likely you think any current approach is going to get us anywhere. That's not to say that we won't eventually have I'm sure, some great biological model of how things work, but we're nowhere near that.
I'm sure that's right.
One last thing. Can you say more about soul and consciousness together, relationship?
Like what?
Well, like how are they related?
You guys did put it in the title.
Yeah, I mean, I'm not sure I have any additional thoughts on it. I have a lot of thoughts on how soul interplays with the other things we talk about, but, you know, I'm not really sure that there's a model of consciousness that I'm very persuaded by. And I think that the best you can say in terms of the relationship is that soul is a good way of referring in a kind of non-scientific but philosophically useful shorthand about what the human consciousness is and what the human consciousness does. You know, some people might find it too freighted with metaphysics. You know, as a non-religious agnostic with a very strong affinity for classical philosophy and for arguments coming out of Jewish and Islamic thought, I think I'm comfortable with it. There are people who are very secularist or who are very concerned about religious and metaphysical implications who just can't handle soul. I think it's useful. I think we could probably come up with another term, but it would be clunky and unwieldy and hard to get people to use. But you know, we're really just talking about the specific human iteration of consciousness and what that means. Do I have any idea about how this fits into consciousness research right now? Yeah. I'm even less of the models that I thought were exciting 10 years ago. Not so sure about.
I'm sure my understanding of the word soul is antiquated. But
well, ours, we've been studying ours for like 2,500 years.
Yeah, so, but it seems to me that I wonder if soul isn't a product of consciousness.
I don't know. At least I'd say almost as there's one argument I read that looked at it from this Buddhist idea, and to some extent Hindu, of the different aggregates of the self. I would say consciousness is sort of the central aggregate of soul, but there's others, right? Like when we talk about agency and memory and the social component, I think those things all go involved. Otherwise, you're just talking about mind. Right? To me, you know, consciousness is much closer to saying mind in a lot of ways than it is just to what you might call soul or. I'm sure Len will have something to say about that too. So
Sure.
Yeah. Didn't you give the Mellon lecture? What's in a soul? So
I did.
Yeah.
All right. Thank you, Greg.